Most of the pipes we've explored this season were built to move water beneath streets, across cities, or between entire communities. But eventually, that water has to leave the main. It has to cross the property line, enter the building, and reach the place where someone turns on a faucet. And for generations, one metal became trusted to complete that final part of the journey: copper. But why did copper become one of the most familiar water piping materials in the world? A city water main can move enormous amounts of water, but supplying an individual building creates a different challenge. The pipe becomes smaller, the route becomes tighter. It may have to pass around foundations, through walls, beneath floors, and between rooms. The material needs to withstand pressure, but it also needs to be workable. It needs to be cut, bent, joined, and installed inside spaces where large rigid pipe would never fit. That is where copper found its place. Copper combines several qualities that made it useful for water service lines and building water systems. It is strong enough to carry pressurized water, but it is also workable. Rigid lengths can create straight piping runs. Softer coils can bend around obstacles and reduce the number of connections needed along the way. Copper can be cut to length, joined with fittings, and installed in spaces where every foot of the route may be different. It wasn't designed to move an entire city's water supply. It helped move that water the final distance to the people using it. Think about this. The water leaving a treatment plant may travel through massive transmission mains, distribution piping, valves, and service connections. But the final section, before that water reaches the faucet, may be a copper tube small enough to hold in your hand. The entire water system can narrow down from pipe large enough to walk in to a line less than an inch across. And every section still has to maintain pressure and protect the water inside. Copper became familiar in water service lines and inside residential, commercial, and institutional buildings. Cold water lines, hot water lines, mechanical systems, and smaller pressurized connections throughout the building. Different wall thicknesses were developed for different applications. Type K has the thickest wall. Type L is thinner, and Type M is the thinner still. They may look similar, but they were not designed for every application in exactly the same way. Copper earned its reputation because it could perform reliably for long periods of time when the material, the water chemistry, and the installation worked together. Its solid metal wall creates a strong barrier between the water and the surrounding environment. It can withstand heat, it does not burn, and when removed, the metal can be recycled and used again. That combination helped copper remain familiar even as newer pipe materials entered the industry. But like every material, copper isn't perfect. Copper can corrode. Certain water conditions can slowly attack the metal. Sometimes that damage appears as a small pinhole leak. The pipe may look solid across nearly its entire surface, while one tiny area has weakened enough for water to escape. Installation matters. Water chemistry matters. The materials connected to it can matter. And copper itself can enter drinking water when corrosion occurs. That is why corrosion control is part of operating a modern water system. Copper teaches us that the largest pipe isn't always the most important one. A transmission main may carry millions of gallons, but the small service line is what completes the delivery. It is the connection between the public system and the person waiting for water. Every part of the system depends on the one before it, and even the smallest pipe can have one of the biggest jobs. Hidden beneath yards, inside walls, under floors, and above ceilings, copper has carried water into homes and buildings for generations. Quietly, under pressure, and mostly unnoticed, until something goes wrong. It became familiar because it solved a very specific problem. How do you take water from a massive public system and complete the final part of its journey? For millions of buildings, the answer was copper. But copper wasn't the first metal used to make that connection. Before communities fully understood the long-term danger, another metal was chosen because it was soft, flexible, and remarkably easy to install. A material whose name eventually became connected to one of the largest drinking water challenges in modern infrastructure: lead. And that's where our story continues. Welcome back to Under Pressure, Underground.